Sip na yun, Hub.
Hi, welcome to the continuation of our presentation on limits. This time, we have a different function. H of x is equal to x squared plus 2x all over the square root of x cubed plus x squared.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
This particular function here has a value at any other x value except for 0, and let us show that. What happens to the function if x is exactly 0, meaning h of 0? This is equal to, let's substitute 0, we have 0 squared plus 2 times 0 all over square root of 0 cubed plus 0 squared. And we see that we have 0 over 0. Everything here becomes 0 over 0. Again, 0 over 0 is indeterminate. This is not a number. However, it is possible that this function approaches a particular limit even if the function does not really have a value at this particular point. And we can investigate that by preparing a table that shows us the value of the function at x values that are really close to 0 this time. Now let us build first our table and then compute for the values of the function later. So this is our x values. This is 0. We know that the function is already indeterminate at this particular point. So this is h of x. What is a number that is close to 0 from its left side? So the left side of 0 is already the negative numbers, so we expect that they are negative. Maybe we can say it's negative 0.1, that's close, or negative 0.01, or negative 0.001. From the right side of 0, it's the positive equivalent of what we have identified. So let us start with 0.1 maybe. This is a number close to 0 from its right. And then we have 0.01, 0.001. Let us identify the values using our calculator. Let us first encode our numerator. Our numerator is x squared plus 2x. And our denominator is square root of x cubed plus x squared. Okay, there we have it. Let us use the calc function to evaluate. Let's start with negative 0.1. Negative 0.1. So calculate that. That's our negative 0.1. The answer is negative 2.0028. Let us approximate again. So we have negative 2.0028. Let me encode it this time to make it easier. We do the same. So calculate at negative 0.01. Our answer is negative 2 and then 4 zeros. We have 25, so it's at exactly negative 2.0. Let me quickly do the rest. There we have it, our complete table. Let us now explore what happens to h of x as x approaches 0 from the left side of it. What happens? It seems that h of x is approaching negative 2. It is getting closer and closer to negative 2. Let us also observe from the right side of 0. As x approaches 0 from the right side, what happens to h of x? It is approaching positive 2. Now, what can we say about the limit of h of x as x approaches 0? Since the limits is not really the same from both sides of 0, we cannot really say that the limit of h of x as x approaches 0 exists. That is because the limits are not equal from the left and then from the right side. So that we would still write the limit of h of x as x approaches 0 still does not exist. We now realize that for a limit to exist, the function from the left side and the right side of a particular number should approach the same number. Although h of x here is approaching a particular number from the left side and from the right side, it happened that those numbers they are approaching are different. This makes the limit not to exist in general. However, if we want to emphasize that h of x has a limit at a particular side, then we may write the limit of h of x as x approaches 0. Now let us specify which side are we talking about. If it's from the left, we write a superscript that looks like the negative side and then equate it to the limit. It's negative 2. Similarly, if we want to emphasize that h of x has a limit as x approaches 0 this time from the right side, we write this symbol as a superscript, the positive symbol, that is equal to positive 2. These kinds of limits, specifying the limit at a particular side of a number, are called one-sided limit. Specifically, we call the first one a left-handed limit. The second one is called a right-handed limit. That's it, our one-sided limits. Click on the link above for the continuation of this presentation.